Lesson 1, Single Component Filters. In Lesson 1, we'll be looking at filters with basically one component, either a C filter or an L filter. Starting off with the C filter, a C filter is a first-order filter. It provides around 20 decibels per decade of attenuation. So when do we use a C filter? A C filter is mainly used when both the source and the load impedances are relatively high. Or in other words, the source and the load are both acting like current sources at that noise frequency. This means that it is difficult for the source and the load to basically sink high frequency current. For that reason, installing a capacitor right there between them would be a good idea, because the capacitor would basically provide a low impedance path for that noise to go. Alright, now, in the case of differential mode, we place a capacitor between the line and the neutral, or if it's a DC system, between positive and negative, as we have discussed earlier. In the case of common mode, we place it between the line and chassis and between neutral and the chassis. Or if it's a case of DC system, we place it between the positive and the chassis and between the negative and the chassis. When using Y caps, be careful not to exceed the limits that are set by some standards for leakage current. L filters are also first-order filters, and they also provide around 20 decibels per decade of attenuation. But when do we use L filters? L filters are mainly used when both the source and the load impedances are relatively low. In other words, the source and the load are both acting as voltage sources. Take, for example, the case of a typical regulator that is feeding a voltage-like load. To give a practical example, in mixed signal circuit design, when we have basically a digital output, a digital voltage output, let's say it's a 3.3 volts digital output that is going to feed an analog input, right? What we do is we usually separate those by using Ferrite beads or by using small inductors. These small inductors will actually act like an AMI filter that will basically separate the noise, the noisy digital signal from the analog input. That way, whatever noise or garbage that digital voltage source is putting on the line is being contained and it's not flowing to the analog input. To give a summary, a C filter is good to use when no one is stiff enough to basically take in or sink the high frequency ripple. In that case, we provide a capacitor to provide a local path for that current to flow. When it comes to L filters are good to use when both the source and the load are stiff voltage sources.